Udata. I am Assistant Professor from Department of Electronics from Walchand Institute of Technology, Solapur. So today we are going to have a session on transactions in database. After the end of this session, student will be able to introduce transaction concepts, state, atomicity and durability. A transaction can be defined as action or series of action that can be carried by a single user or application program to perform operations to accessing the contents of the database. So transaction is nothing but it's a set of operations that you are going to perform on the database. So when you begin the transaction, the database is in consistent state, and at the end of the transaction, the database also should be in a consistent state. And during the execution of the transaction, the database might be temporarily in inconsistent state. The main prerequisite that is to be followed is when you are performing a transaction, the database should be in consistent state even after the end of the transaction. What type of operations can be performed? Like retrieval, nothing but reading of the data, insertion, nothing but writing of the data, and deletion and modification. Transaction is a sequence of read and write operations that can be grouped together to form a database access. So there are different types of operation. Retrieval means to retrieve the data stored in a database. Insert, that is nothing but to store new data into the database. Delete, nothing but to delete existing data from the database. Update, to modify the existing data into the database. Commit, to save the work done permanently, and rollback is to undo the work done. So these are few sets of operations that you can perform on the database. But one thing you should keep in mind, before starting the transaction, the database is in consistent state. But when you complete the transaction, the database also should be in a consistent state, else you will have an inconsistency in data. Why do you need consistency or concurrency in data in transactions? A database is a shared resource. It is used by many users and processed concurrently. Like for example, banking system or the railway reservation or air reservation systems, or even the stock market. There are millions and billions of users who are working with the database, and they are concurrently they are using the database. Whenever the transaction is processing, at the end of the transaction, the data should be consistent. What happens if the consistency or concurrency is not maintained in database? It might lead to hardware failure and the system may crash, concurrent execution of the same transaction, deadlock may happen, or there is a slow performance. Transaction execution and problems. When a transaction is completed, it is successfully executed, then the transaction is committed. If it is failed, the transaction is aborted. Thus, if a committed transaction performs any update in the database, its effect must be reflected in the database. When a transaction is successfully completed, whatever the data is to be done, whatever operation is to be done, it should be updated into the database. If it is not reflecting, the transaction is considered to be a failure. What is a transaction state? First comes the active state. Active state is the first state of every transaction. In this state, the transaction begins. The transaction begins in the active state. Next is the partially committed state. In the partially committed state, a transaction executes its final operation, but data is still not saved into the database. So, partially committed is an in between. The transaction has started, but it has not been finished. It is in the middle of the finish line. So, data is not saved into the database, hence referred to as partially committed. Next is the committed state. What is a committed state? A transaction is said to be in committed state if they execute all the operations successfully and the data is stored permanently into the database. So, whatever operation like update, delete, insert, whatever the operation transaction is performing, it is successfully finished and you are updating the database permanently. So, that state is referred to as committed state. So, active state you begin the transaction, committed state you are in middle of the finish line, you have not yet completed, the data is not yet updated into the database, it is in middle of the finish line, and the committed is what? It is successfully transaction is completed and the data is also been updated into the database. Next is the failed state. If any of the checks made by the database recovery system fails, then the transaction is said to be a failed state. So, if there is some failure, okay, if there is a system failure, then the transaction is said to be in failed state. For example, total marks calculation. If the database is not able to fire a query to fetch the marks, if the database is unable to fetch the marks, how can he complete the total marks calculation? Yes, then the transaction is said to be in a failed state. These are the types of transaction states. Aborted state. There is one more aborted state. If any of the check fails and the transaction has reached the failed state, then the database recovery system will make sure that the database is in its previous consistent state. System is failed and transaction is failed, then in this case what happens? The database recovery system has to fail the transaction, has to abort the transaction and has to make sure that the database was previously in the consistent state, then he has to go back to its previous consistent state. As the rule of transaction says, if the transaction is in a consistent state before the transaction, then after the transaction also the database should be in a consistent state. If it is not, abort it and go back to its previous consistent state. So, there are two operations in the aborted state. First, the restart the transaction and to kill the transaction. So, these are the 5 states of the transaction states. Next is the acid properties. What are acid properties? Acid properties are used for maintaining the integrity of the database. During transaction processing, acid in DBMS stands for atomicity, consistency, isolation and durability. First comes the atomicity. A transaction is a single unit of operation. You either execute it completely or you don't execute it at all. There is no partial execution of a transaction. So, atomicity is you either do it completely or you don't do it. Though there is not partial execution of the transaction, that is referred as an atomicity. Next is the consistency. What is consistency? Once the transaction is executed, it should be moved from one consistent state to the another. So, previously before the transaction, it is in consistent state. After the execution of transaction, the consistency should be changed from one state to the another state. Next is the isolation. Market trading, number of transactions are happening in a minutes. Okay, so there are millions of transactions going simultaneously. So, it is a need for maintaining isolation between the transactions. So, during concurrent transaction execution, intermediate transactions result from simultaneously executed transaction should not be visible to each other. So, if I am buying something on the trade market, then you cannot able to view my transactions. So, you cannot view my transactions. All the transactions should be isolated from each other. Next comes the durability. After successful completion of transaction, the changes in the database should be persist even if the system failures. So, whatever changes you are going to do after the successful of the transaction, the database should be maintaining or persisting the changes even in the case of system failures. The all or none property is commonly referred to. Pause the video and answer the question. If you are not able to answer, review my video and try to answer the question. Answer to the question is atomicity. It ensures that work is either completely done or not at all done. So, there is no intermediate stages or there is no partial execution of the transaction in atomicity. References are taken from database systems, concepts from Korth, Fundamentals of Database Systems by Ramesh Ilmasi and Shamkan B. Naute. Thank you.